Is everyone able to hear me okay? Super. Okay, well, thank you for having me. Thank you for the introduction, Joe, and Ashley as well. There's a lot of hard work that goes on behind the scenes, and I'm really proud to see so many people who love their craft so much that they'll come out early on a Saturday morning. I'm one of those people, and I'm going to share with you a little bit of my journey through data virtualization. If at any point you guys, this mic's not really the best to deal with. If at any point you can't hear me, just go like this, and I'll know that I need to speak louder. So I'm going to share with you my journey through data virtualization and talk about a really interesting emerging subject, and that is defining a logical data warehouse. And the history of data virtualization, which is really the base. Before we can design a logical data warehouse, we're going to need to virtualize our data. And so the real core idea here is that a warehouse that is easy to think about is a warehouse that's easy to maintain. So that's what we really mean when we're talking about designing a logical data warehouse. And the thing which I find really curious is the birth of data virtualization was coincident with the birth of SQL. So how many people know Edgar Cod, have heard that name, Edgar Cod? Okay, great, so everybody, right? A lot of you have probably read his foundational paper. How are we doing on volume? I know there's a sweet spot for this mic, it just moves. How are we doing there? Good, okay, super, let's run with that. So Cod wrote the original foundational paper way back in 1970, and he set out normalization, he set out relational database management, and there's an interesting story there. And so right in 1970, a very young Larry Ellison read this same paper that Cod had written, and Cod really wanted to get IBM, he was at their San Jose research facility, and he wanted to get them to move, and he thought that this was going to be the future of data management, and this was the right way to do things. IBM, being a large corporation with this saturnine inertia, decided, well, we're not really sure that we want to cannibalize our existing product lines. So Ellison went off and on this race, he knew this was the right way to do things, and he started to develop what would turn into Oracle. And Cod, being an interesting character, he couldn't get IBM to move, so what he did was he went directly to IBM's customers and said, hey, wouldn't you love to have this? And they said yes, and they then turned around and pressured IBM to release this technology. Now, the interesting thing about this is in the opening paragraph of the paper, he describes what we would call today as data virtualization. So future users of large data banks should be insulated from the details of the machine, how the data is organized in the machine. Now, the fascinating and prescient thing about this is that this defined data virtualization. The depressing thing about this is 50 years later, we're just figuring out how to do this. And we'll talk about what some of the reasons are for that. So I'm going to break today's talk down into three principal sections. The first is going to be the theory behind the design, behind logical data warehousing and data virtualization as a whole. The second, we're going to talk about some of the emerging technologies. This is a really exciting time to be in data because there's just some tremendous open source projects and even some enterprise projects right now that are doing amazing things. And we'll talk about some of the new performance numbers. We'll talk about some of the new methods for designing and implementing a logical data warehouse. And lastly, I'm going to talk about psychology. There, I think I hit that spot on the mic there. So we're going to talk about psychology. And this is not something that you would typically expect to hear at a technical talk, but I think it's really important to remember that software is built by human beings for human beings. And there's a book out there called, which we used to use at Microsoft, called the Software Project Survival Guide. Does anybody remember that book? So the key insight from that book is software is a conversation. And the better the quality of the conversation inside the organization, the better the bits that you produce. And if we're really serious about producing a logical data warehouse, which is a data warehouse that is simple to think about, we're going to have consensus inside the business about what the business means to all the stakeholders. And that's where the conversation comes in. So in my world, these are my three laws of software development. They're probably contrarian, but they're what I found to be true. So the software is the conversation part we've covered. Software is late and it's never right. It's always late and it's never right. I have never, from Microsoft down, I have never worked on a software project of any appreciable complexity that was delivered on time. And it's never right when you deliver it. It just gets progressively less wrong over time. And really, once your users start to touch it, that's when you learn what you really needed to build. And this is the beautiful thing about software. It's like a computation that you just have to run to see what the result is, right? So if any of you know how the halting problem works, there's no way that you can create a computer that will tell you whether or not a program will halt. You just have to run it and find out. And I think this is the way that software development works as well. And the reason for this is that the components are fallible, right? So we have human beings in the equation who are operating with incomplete information, and then we have this highly super dynamic environment. And that environment includes a changing market, changing products, changing economies, and there are so many variables moving at once that it's really, really hard to get things right. And the natural response to this, the only thing we can respond to, and the core reason why we would want to do logical data warehousing in the first place is agility, right? So we're going to start with the admission, we know we're going to get things wrong, and now we have to develop a system which allows us to iterate very quickly. That's the core idea behind agility. And in order to have agility, you have to have simplicity, right? A logical data warehouse, or a data warehouse that's easy to think about, is one that's easy to maintain. And the core of simplicity is really abstraction and encapsulation. So those are the two foundational principles of data virtualization. Those are the core principles. And everything that we're going to look at, we can derive from those two core principles. I want to establish need for a second here. Just looking at, you'll notice in brackets on the top bullet there, those are my citations. So I have a fairly extensive bibliography, which I'll reveal at the very end. And I'll make sure, with Joe's help, that I publish these slides online. But when you see in brackets, I'm referring to an external source. So we're looking at, 66% of businesses are integrating 6 or more different data sources. We're going to call that federation, or federated sources, throughout this talk. And the dirty secret with cloud computing, as amazing as it is, and as scalable as it is, and as turnkey as it is, cloud actually makes things more complicated in the beginning. And we're going to see that data virtualization and logical data warehouses offer us a way to insulate ourselves from some of that complexity. Data enrichment, how many people have behind the firewall data that they want to integrate with public data, do enrichment? Okay, so enrichment means we have more sources, our federation is getting more complicated. A huge percentage, you can see fourth bullet there, of business intelligence efforts are just finding and integrating data. 70% of the time. And that leaves so little time for actually generating insights. The other thing which really kills me is only 28% of users have meaningful access to data. That means you're looking at 70% of your organization would love to have data and could make better decisions, they just can't get to it. And the conceptual model that I like to use for this is something called dark data. And the idea behind dark data is that there's this beneficial data out there, but you're not using it. It's kind of like dark matter in the universe. And so there's all the dark data out there in the world. There's the data that you're warehousing, and then that little green circle is the small fraction of data that you are actually using. So another way of thinking about logical data warehousing is we're shedding light on the dark parts of the warehouse, and we are getting not just the warehouse, but the data in the world, and we're reducing our dark data by giving people more actionable data so they can make better decisions. At the end of the day, technology is not important. We want to make sure that we give people higher quality information so they can make higher quality decisions out the other end. It's very simple. The incentive. So why would anybody want to do this? Well, I mentioned the number one already, and that's that decision quality is the thing that really matters. Data quality is another one. And without data virtualization, without a way of getting on top of all of your federated and multiple data sources, your data quality just absolutely goes into the toilet. The other thing we're going to talk about is lower costs. Agility is right there, shorter development cycles, improved access and security, right? Security is hard enough. If you have a really complex data warehouse architecture, if you have an architecture that's hard to think about, you are going to have a heck of a time securing it. Scalability, real-time access. How many people are doing service-oriented, like REST architectures out there? So service-oriented architectures, great. So you're going to find it a little bit easier to support SOA architectures with reuse, with data virtualization and logical data warehousing, and reduced sprawl, right? So that is the enemy of every DBA in this world, and that is duplication and denormalization of logic. Now, in 2017, storage is really cheap, right? That's not why we're worried about sprawl. Why do we care? Why is sprawl a problem? Sorry? Yes, that's it, right? It has nothing to do with cost, it has everything to do with time, it has everything to do with reducing our agility. If we have to touch the data in 7 or 8 or 9 places, that means more development time, that means there's a longer cycle time for our business stakeholders to get the data, it's a nightmare. And so we're going to talk a lot about consolidation as we look at the virtualization architecture. So this is a lot to look at, and I'm going to talk about a little bit of each component at a time. So the first thing I want to do is just present to you the idea that virtualization is a layered architecture. No surprises there. What did they say? Stephen Hawking met a woman who claimed that the Earth was resting on turtles, right? And he said, well, what is that turtle resting on? And she said, you're very clever. It's turtles all the way down. And the idea in virtualization is that it's views all the way down, right? So I just want you to look at that frosted glass pane, that green box on the right now. We're going to talk about each of these layers in detail, But starting from the bottom there, that's you can think about it, those are your federated sources. You have multiple data sources. So those two circles on the bottom, you could imagine there could be a production database in there could be a mobile app, there could be a website, you've got multiple sources. The first thing we do in the virtual base layer is that's the first layer of insulation. And so for each one of the incoming sources, we create a view. That's all the virtual base layer does. It's a one-to-one mapping with our data sources. The next layer is the enterprise data layer. This is essentially where your business logic lives. So you can imagine if we have customer data coming in the bottom at the sources, we're going to map those one-to-one into the virtual base layer. And in the enterprise data layer, we're going to make a business object out of that. We're going to make an actual customer out of it. In the shared specs layer, we're going to do any deduplication that we can do. We're going to start doing permissioning as well. And finally, in the data consumer layer, we are going to present the data in a way that makes the most sense for the users. Okay, so I moved from the bottom to the top. Okay, and so upper right in that green box, you see there we have our reporting, we have our analytics, we have our dashboards. That's going to be your apps are going to be Tableau, are going to be Domo, are going to be Spotfire. Does that make sense so far? So what we just did was we traced a datum all the way from the bottom to the top. Okay, and now I'm going to go and talk about each one of these layers in greater detail so you can understand how you can apply this in your own work. So let's talk about sources first. So this is, I think, where the pain really starts. And there are just such a wide variety of sources out there, and you feel velocity, variety, variation. You're feeling all that pain of this data flowing into the warehouse. And so you've got enterprise service buses, unstructured data, social media, user events, CRM, private data, public data that you want to integrate. There's just a bevy of data that's coming in on the sources layer. So on the apps layer, we talked about that a little bit already. So I'm at the extrema now, the very top layer and the bottom and the very top of the diagram. We're going to look at the virtualization layers in just a second. So this is where you get the payoff of doing logical data warehousing. And this is the painful part actually for most integrations today. You've got production apps, mobile apps, dashboards, internal portals, websites, the whole nine, all the way at the top there. I really like to think of this as the business intelligence layer because that's one of the key apps that all of us are trying to drive. And the important thing here is that when you have a virtualized architecture, what you're able to do with this logical data warehouse is you may change any of the layers beneath them, but because that data consumer layer is virtualized, you don't have to touch your apps. And that's really where the agility starts to come and is from the insulation, which is again a product of these first principles that we talked about, encapsulation and abstraction. So is everyone following me so far? Super, okay. So now we're going to go into the gray boxes there are actually where the virtualization takes place. Okay, the orange box and the teal box top are standard, and you already have those pieces today. One more comment. Does anybody notice anything about the direction of data flow in this virtual or logical data warehouse?
Yeah, you're going the wrong way.
Okay, that's one way to think about it. So the data's all going in one direction, right? So how many people are familiar with Facebook's Flux architecture? So it absolutely merits a look. It's amazing. And one of the things that Facebook found was that in order to build a predictable architecture and an easy to maintain architecture, you want unidirectional data flow. Because when you get into data loops, when you get into these self-influencing loops, that's when software becomes really unpredictable and where you get bugs. And so in the Facebook architecture, they actually have a serializer which sits somewhere near the sources layer and does nothing but serialize events, so you only have unidirectional data flow. I think that's a really great cue in terms of building predictable, low bug count architectures, is you want this unidirectional data flow. Great. So let's go into the virtualization layers now. So you got the virtual base layer at the bottom. I already explained this. This is a one-to-one mapping to all your data sources. The other thing is that you do some data cleaning in this layer. And data cleaning in a virtualized data warehouse is a little bit different than what you might be used to with your standard ETL programs. I want to mention just 5 different techniques that you can use when you're cleaning up your data. One, and this is actually not as stupid of an approach as it sounds, is just to do nothing and pass the data through. And the reason is, in this layered architecture, as the data percolates up, we'll have the opportunity to clean it up later. We can filter out rows that we think are faulty. We can filter out values within those rows. The approach that I really like is called flagging. And the idea here is that if we find data that we suspect in terms of equality, we can just flag that data. And the reason I like this approach is that downstream, your operations people, your IT your data scientists even are going to want to see that dirty data. We shouldn't be hiding it from people. So with flagging, we can do some very simple low-cost filtering inside the views as people consume the data. And then there's restoration or reconstruction, which is actually fixing the data. And so in my opinion, as we move up the data virtualization stack, those are better opportunities to actually do your data cleanup. The next layer is the enterprise data layer. So I think about a third of you had read Codd's paper. How many people remember third normal form? Oh, wow, okay, super, right? It's great to talk to a technical audience. So quick refresher, third normal form, all of the attributes depend on the key, the whole key, and nothing but the key. So at the enterprise data layer, what we want to do is really normalize the data because the rest of the data warehouse is going to be consuming from this layer. And this is our chance to really make things clean. This should be a relatively neutral layer. When we get all the way towards the top of the architecture, we're going to be able to do tailoring for individual users. But this is where the magic starts to happen and where you build up your business objects that the rest of the data warehouse can consume from. And how many people are familiar with master data management? Right, so if you have multiple data sources, you want to do entity resolution, you want to manage keys across multiple tables, then this is the place that you're going to do that. Any questions or comments so far? Is everybody following me? Good, yes? Okay, super. So moving up to the next layer, this is the shared specifications layer. The important thing that I want to emphasize here is access control. And it's also important, the agility in some sense comes from the shared specifications layer, and we'll see why in just a moment, but here's where you're going to do your deduplication. So if you have data consumers that are consuming the same types of data in the layer above, you're going to go ahead and consolidate those here in the shared specifications layer, and you're introducing permissions and security. Okay, the data consumer layer. This is where we simplify things for presentation and we present things in a way that are logical to the user. So some people are going to want star schemas, some people are going to want snowflake schemas, some people are going to want to look at giant tables, some people are not technical at all, just want the data in a format that it's going to go into Tableau cleanly. And the data consumer layer is where we do all of that customization. Filters, projections, transformations, aggregations, that all goes here. And from a performance perspective, and we'll talk in detail about how logical data warehouses perform, you're also going to want to do your caching in this layer, in the data consumer layer. So that is the stack as a whole. The nice thing about the architecture, we've talked about unidirectional data flow already, is that it's not really meant to be a dogma. We're going to go through some case studies and see how this architecture actually performs in the real world. But we're going to find out that layers are really, really cheap. And this is a suggestion, a serving suggestion, like you see on a frozen TV dinner box. You're going to have to customize this for your own environment. A quick note on vendors. The two leaders that I'm aware of, I think there are more out there in data virtualization, are Red Hat. They're doing JDV as part of their JBoss product, and then Denodo. Those are the two, if you're looking for out-of-the-box virtualization stacks, those are two places where you can start.
Cisco has one too.
Oh, cool. Cisco, thank you. All right, so let's dive into a little more detail here. So the first thing that I want to draw your attention to is we have these 4 layers. It's considered good practice for agile data management that you carve out an administrative sandbox. Okay, so what I'm showing here with that admin line on your left there is that the first 3 layers you'll want to expose to your IT staff so that they can actually administer the data warehouse. And the beautiful thing about virtualization is that you can do this in a way that is insulated, and they can work on the data warehouse, they can customize it, they can configure it, they can optimize it without really affecting the downstream applications, as long as you do things in an encapsulated way. The next one I think is really important, and that is, how many people have heard of self-service IT? Okay, so this is extraordinarily important, and speaking to a room full of DBAs and IT admins, I really want to drive this point home that it is impossible to have an agile business if you think that IT and the DBAs need to build all applications for everybody. It does not scale, right? And so go back to what we said earlier about human beings being fallible and software never being right. You have to give people the authority to roll their own. You have to give them that kind of autonomy because they understand their problems better than you actually do. We'll talk about this more in the psychology section. But the carrot for all of you who are paranoid, I know users do terrifying things with data. And there are good reasons why DBAs are leery of giving users the keys to the kingdom. And the beautiful thing in a virtualization architecture, you don't have to do that. You have all these layers of insulation, and users really only need to touch the top 2 layers, the data consumer layer and the shared specs layer, and they can write bugs all day long, and everybody else in the warehouse is going to be none the wiser for it, because all they're doing are creating modifications to thin views. So I really love this architecture for helping companies to work better together and for there to be more trust and autonomy. Because when you hold on, when you grab that steering wheel and like, no, we're the only people that have access to the tables, we have to control permissions, you're depriving people of data. And so this is a safe way for you to start letting other people play in the data warehouse. Let's talk more about this. So Gartner developed a term for this. He called it bimodal IT. And the idea here is that mode one information technology, let me see if I can do better. This thing is really bugging me. The idea is that mode one information technology is the standard top-down approach, right? So the DBAs are going to really quality. And mode two is the users focusing on time. We're going to talk about that trade-off in just a moment. But that allows them, it's called everyday design. That allows them to build solutions that are customized for them and not have to ask anybody for permission. And that's the way data should work. I already mentioned the sandboxing that you get. The other thing that you get with this architecture when you allow people to self-serve is you can use DBAs for things that they're good at, right? DBAs should be focused on architecture and optimization and performance tuning. They should not be gating pushes to production. If a developer wants to put stored procedures into production, the developer should have the authority to do that directly, right? So 64% of orgs are struggling with self-service BI, and 1 in 3 are rating their self-service terms fair or poor. So I think there's a really strong need for this, and I'm really passionate about this. And if you're working on this in your organization, I want to talk to you. Okay, let's talk about implementation order. So one of the things that you want to do is figure out if you want to virtualize or logify, so to speak, your data warehouse, what order you're going to tackle things in. The bottom-up approach is actually, although that is the correct direction for data flow, that's not the order in which you want to develop things. Can anybody guess why? Because then the structure of your data is dictating what the users see, and you don't want that. You want to, well, conceptually you want to work top-down. Top-down has a different problem. So if you start at the top of the data warehouse, you start at the data consumer layer, and then work your way down to the virtual base layer, what do you get? What's that? Yeah, in some sense, or you get a tremendous amount of duplication. So the preferred approach is actually inside out. So start at the enterprise data layer, get your business objects right, go down to the virtual base layer, come up to the data consumer layer, and then do the shared specs. And I will link, I know this is a lot of information at once, but I'll link to the white paper so you can all read this. It's all explained in much greater detail there. The key point here being is that because it's a virtualized architecture, once you have these layers of insulation, you can just pass data through. You can have a working virtual base layer and a working data consumer layer and nothing in the enterprise data layer or shared specs layers, and you can just work on those while people are using the data warehouse. It's really a beautiful aspect of the design. And that's, again, that encapsulation. So performance optimization, I think all of you are experts in a lot of these things. You can cache the views, right? You want to focus on caching at the top layer where users are actually consuming the data. At the bottom layer, you can also do that. It becomes a little bit more complicated. You only want to get, you remember the two hard problems in computer science, right? Naming, cache invalidation, and off by one errors. You only want to get into, nobody got that joke. You only want to get into caching when you have to, right? So we'll start at the top layer. This is all standard stuff. Indexing, so remember we have views, right? So all of your cache views, you want to index the primary key. And if there are any indices to foreign keys, you also want to index the foreign keys to other cache views, right? Simple performance stuff. Filtered and aggregated columns obviously need to be indexed. You're going to get an order of magnitude improvement on your performance. Keeping the statistics up to date, right? This really, in essence, amounts to letting the query optimizer do its job. So all of the hinting that it needs to develop efficient query plans, you want to make sure that that data is up to date. And there's really simple stuff, which we'll talk about more later, minimizing your network traffic, right? I/O is slow. That's like the one reliable law in computer science. Questions or comments? Yes?
Do you see any challenges with data that has to be dark, like in HIPAA for healthcare or financial institutions have to have personal card information locked from the users so that there's controls on it?
Yeah, so the question is whether there are any challenges with data that quote unquote has to be dark, right? And the HIPAA data is the one that comes to mind. So I want to finesse the way that I define dark data as data that is beneficial but you don't have access to. So inside your data warehouse, there's a difference between data that needs to be secure and data that needs to be dark. That's the first distinction that I'll make. The second piece is that this architecture lets you hand roll permissions and views very, very carefully, and that's extraordinarily important. So any data hiding you need to do can be done in the shared specification layer, right? Which is where it's an excellent question, and I'd like to talk about it more at the end. Great, and then there's all the standard things like, this is what DBAs excel at. hand tuning, partitions, buffering, solid state drives. Hardware still makes a difference. SSDs obviously have been a huge performance boost. How many people out there are using solid state drives? Okay, cool. All right, so moving right along. How does it perform in the real world? This is the million-dollar question. I think everybody here is familiar with the TPCH benchmark. TPCH actually has a flaw, and it's not designed for federated environments. So Red Hat actually sponsored a study done by a third party where they took the TPCH benchmark, modified it for a federated environment, and I want to give you the high level of what they learned from a performance standpoint. Quick review, how many people are familiar with TPCH already? Okay, great. So quick review, it's just real world data. Okay, so they had 4 different databases, so 4 federated sources, a terabyte of data in each one of them, and real world loads, like 150 million customers, 6 billion order line items. And what they found were 2 things really important. So I want you to look towards the bottom. I know it's a ton of bullet points, but towards the bottom. So there's almost no query overhead for virtualization. Actually, if you read the paper, the overhead is negative. Right? So it's actually faster with virtualization. The second thing is you can pump as many different sources into your logical data warehouse as you want, and performance gets better and better and better. So where you're really going to kick ass is where you need federated data. If you have multiple data sources, you're going to see a huge performance gain from data virtualization. And layers are cheap, right? So this is the idea, is you can add, those layers are very thin. You add as many layers as your business needs to succeed. All right. So that is the virtualization stack as a whole. I want to now talk about high performance teams. So we've talked about what it takes to build a high performance architecture. The question now is, how do you build a high performance team? How many people are familiar with Conway's law? Have you heard that term? So Melvin Conway, studying organizations, I think back in the 70s, he found that he was looking at different projects, and he noticed that there were 3 different teams working on a compiler, and they built a 3-pass compiler. And so he had this profound insight, which was organizations are constrained to produce designs that mimic their communication structure. And this is the hard problem. The hard problem is not technology, it's people. And the hard problem I want to pose to all of you is, if you want a data warehouse that is easy to think about, you have to get everyone in your company talking. You have to agree on what the single metric is that drives the business. Otherwise, you will have chaos. Logical data warehousing will not save you. At a very high level, at a spiritual level of the organization, having a logical data warehouse means you can get everybody in the company to agree about what you do and how that's important. So Google and others have done some work on what makes for high performance teams. The #1 factor is psychological safety, which is the ability to take risks and be trusted by the people in your team. Meaningful autonomy and ownership. So this is what I was talking about before. Remember carving out the self-service layer and the top 2 layers of your logical data warehouse? The people who are closest to the problem are the ones who should make the decision. When you don't allow that to happen, people get frustrated and they quit. Or they just resign themselves to doing whatever, right? And so the beautiful thing about this, of having technological encapsulation, is that we can give people more freedom. Alignment and shared understanding. And I'm going to work on shared understanding in just a second. Alignment means that everybody in the company is moving in the same direction. How many businesses, I want to show of hands, how many people know the 1 or 2 metrics that matter for their business unit? Okay, I see like 2 hands. All right. How many people are collecting way more data than they're actually using? Almost everybody. So that is a psychological problem, right? And it's not that people are sick, it's that the organization is sick because there isn't enough communication and there isn't enough clarity. And the hammer that you have to go to your C-levels and go to your team leaders with is like, look, if you don't give us the clarity on why we are building this and what number we're trying to move, we're not going to finish on time. You know why? Because the problem's ill-defined. Okay, so moving along, we're going to talk about how we can develop shared understanding through theory. And I want to go through now what I think are the hard and fast laws. These are like the laws of gravity, the laws of physics for software development. How many people have seen the iron triangle of software development before? Okay, personal opinion, if you are a business that depends on software, every single person in your organization needs to understand this. It's very simple too. Time, features, quality, pick 2. You can't have all 3. It's a law of nature. You will not be able to do all 3 things at once. It's impossible. And I'll show you why in just a second. And C-level executives are famous for asking for all 3. And they need to support their organization by realizing we cannot do all three of those things at once. And we'll talk about why it's very easy to see, just to give you some intuition. If you have a short amount of time and you tackle a ton of features, your quality is going in the toilet. And everybody needs to know that that's what's going to happen. So so some of these are theories and some of these are theorems. How many people remember CAP theorem? Okay, great. So foundational to database design, it's another pick two. When you are designing a database, you get two of consistency, availability, and partition tolerance. And I just want to look at my time here. This is a hard and fast rule. And I want to draw your attention to a white paper that just came out. So Eric Brewer, who is the original author of the CAP theorem, wrote a white paper on spanner, true time, and the CAP theorem. And Google has a database which is now open and available to the public called Spanner, with universally consistent timestamps, which is technically a CP system, but it's effectively CA, consistency and availability. And let me explain at a very high level what this actually means. So zooming out for a second, partition tolerance is not negotiable. Partitions are going to happen because the network isn't 100% reliable. So that leaves people to have to choose between consistency and availability, and that is a very, very difficult choice to make. Here's the difference between theory and practice. It is theoretically the case that you cannot have a system with all three, but in practice you can develop a system with enough trust in the consistency that you actually get something like a CAP system. And without getting too technical, I'm happy to field more questions at the end. That's the gist of what I'm talking about here. And what I want to draw your attention to in the pie chart there is that if you look at, people are always worried about technology, but to my earlier point about people being the hard problem, look at the downtime for Spanner. 50% is user screw-ups. Right? It has nothing to do with technology and everything to do with how people are conversing. And if you even go to the number 2 cause there, it's still users, it's bugs. And finally, the actual downtime caused by network partitions is a very, very small slice of that, just 7% of people. Okay? We'll talk more about the CAP theorem in just a moment. Kurt Brown from Netflix, he's Netflix chief data architect. He has something that he calls the FLES theorem. Okay? And it's not really a theorem, it's a theory. I hope to prove it one day. It basically says that in databases, you get 2 of flexibility, scale, and speed. And you can kind of see that, right? So you've got Hive there on the edge. So Hive is flexible. It's got infinite scale because it's built on top, well, arbitrary scale because it's been built on top of Hadoop. And guess what? It's slow, right? Then you've got MySQL on the other side of the equation there. It's flexible and it's fast, but you can't scale that sucker. And then Cassandra at the bottom, so you got scale and speed, but you don't have the flexibility, right? And from that scale and speed, you really have to structure your data in a way that is endemic to Cassandra, and as a result of that, you lose your flexibility. So I want people to be aware that designing a logical data warehouse is a series of trade-offs. You're never going to be able to do it all, and the more that people in your organization understand that there are trade-offs inherent in what you're building, the better you're going to do. And this equation kind of puts it all together, and it essentially says that defects are features over time. And think about this for just a second. If you have a lot of features in a small amount of time, your defect rate is going to skyrocket, right? If you have a small amount of time and you want your defects to be low, you're forced to do what? You have to cut features. There's no way around that. All right, trade-offs. Thank you. Okay, so let's talk about technology for a second here. And this is a really exciting time to be working in data, and I want to give you guys a really kind of turbo overview of some of the really neat technologies that are out there, because I think they can make a big difference for some of the work that you're doing. So my first comment is SQL isn't going anywhere. So SQL as an architecture is probably on its way out. SQL as a query language will be here forever. And I cannot think of an emerging major technology that doesn't support SQL as a query language. Presto, Hive, Spark, Drill. There's just like project after project. SQL is a great way to think about querying your database. It's probably not the best way to structure your data, if that makes sense. So quick comments on each one of these technologies just to give you all a feel for the landscape. So Hive is probably on its way out. And the reason is just to its right there, that's Presto and Spark are just so much faster than Hive. One aspect of Hive that's not going to go anywhere is the Hive metastore. So Presto, other databases are all using the Hive metastore to essentially discover types in tables, where tables are located. That's huge. That's going to be around for a long time. Hive is a querying engine on its way out. Presto is an open source database that Facebook put out there. It has a lot of credibility, A, because it operates at Facebook scale, and B, because it's just amazingly architected and it's fast. The main trick with Presto here is streaming tables, right? So everybody is familiar at some level with joins. And so the idea in Presto is that you have a small table you want to join to a big table. Well, you put the small table in memory and you just stream the big table through and you never land anything to disk. Performance is great. It's all schema and read. Spark, I just got back from Strata, and this is like the most vibrant community out there. It's tremendously flexible. You can do ML in Spark. You can do general cluster management in Spark. You can do data science in Spark. It's very accessible from a wide variety of languages. And most importantly, very, very strong community around Spark. How many people use S3? Really? Oh, that's so. What is everybody else using for blob storage if not S3? I'd expect to see a lot more hands. Okay, Azure. Great. Okay, so similar idea here. Funny story. Was anybody affected by the S3 outage? Okay, yeah. So I was. Very painful. Well, during the S3 outage, the world is burning down. And by the way, that was another deployment screw up. So there was a developer who was supposed to take, I don't know, 10 nodes out of rotation so they could do some service, and he tacked like an extra 0 or 2 onto that and just took the whole thing down. It has nothing to do with technology. Yeah. Okay, so this was the availability matrix during the S3 outage. Does anybody know why it looked like this?
They didn't update.
Why not?
It's not a service.
Almost. So the graphic, the little X, the error graphic, was stored on S3, so the web page couldn't update it. Yeah. Yeah. It's funny until it happens to you. So a quick point on Kafka, you can put, Netflix is putting like 500 billion with a T events per day through Kafka. So if you need a scalable input data stream, Kafka is the way to go. I'm gonna have to skip over a couple things so that we have enough time. How are we doing on time, Joe? Okay, super. I think I'll be able to finish just fine then. Okay, so a quick point before we talk about file formats. How many people are familiar with columnar serialization? Great. I just want to make a couple points as to what makes columnar databases and columnar serialization faster. The first is very, very efficient to compress, right? So if you think about how something like run length encoding works, within a column, especially with low cardinality, you're going to have tremendous repetition of values. They're going to compress very, very efficiently. As a result, they're going to use less memory. You can also play some great tricks which essentially allow you to serialize your data in a binary format that can be read right out of a disk into memory. So there's no parsing that takes place, just a copy. The thing that columnar databases suck at is like if I want to do select star from users where user ID equals blah, columnar databases are going to barf. Why? Barf really isn't the right word. They're going to be slow. Because you have to go and fetch all those columns and kind of do the join in memory. What I want people to be aware of here is that Parquet is one of the leading formats. I hate to do disservice to the rest of them, but long story short, if you're working with row-based JSON data, Avro is where you want to look. Parquet and Orc are kind of the better, well-established alternatives for storing columnar data. Parquet probably has the most momentum right now. Orc has a few performance advantages, and there's another emerging, I think it's an Apache incubator right now, called Carbon Data, which tries to address the problem that I just mentioned. You can put related columns in buckets, and you don't have this typical performance value that you get when you try to do a join from columnar data. All right, we're almost there. LLVM. So this is actually a compilation technology, and you're going to wonder why I'm talking about this at a data conference, and I'm going to explain why. So the important thing about LLVM is the architecture. This is a low-level virtual machine, and all of Apple's compiler infrastructure runs on top of LLVM. The idea here is, again, abstraction. You can have a front end for any language that you want, Python, R, Spark, doesn't matter. That creates an internal representation. LLVM's only job is to optimize that internal representation. So this effectively gives you a compiler that works for all languages, and then you have a backend which emits your code. We'll explain why this is important in just a second. The most impressive thing that I'm seeing coming out now is something called Weld. And this came out of Stanford InfoLab. And I want to explain just a little bit how Weld works and how this actually relates to logical data warehousing. So we saw that we had this network diagram earlier, and we had a data flow. So this is called a directed acyclic graph. It's a really effective way to represent computations, okay? And all I need people to understand from this graph is that the nodes represent compute work that's happening, and the edges represent network traffic, or I/O. And the hard problem that Weld is solving is that you can have micro-optimized, super fast nodes but then lose all of your performance when you actually start shuttling data around. And so the problem that Weld solves is it takes a variety of input languages, optimizes them into a common runtime, and then emits high-speed binaries for each of those computation nodes. And the secret sauce of how it works is essentially lazy evaluation. So none of the query data is materialized until it's actually needed. And I want to really show some groundbreaking charts. I'm just going to give you the highlight. If you look in the lower right there, oh, well, let's start in the upper left, right? So here we have TPCH. This product is like 6 months old, 10x speed up on TPCH over Spark SQL, which is already highly optimized and highly performant. Lower right there, we have Pandas and NumPy with no changes to the existing code base. You just swap out some Weld optimized routine, 2 orders of magnitude performance. This is insane. 100 times faster from doing almost nothing, just connecting to these Weld routines. I would love to talk about this in greater detail. I don't think that time really allows. I'm happy to field questions on that towards the end. Apache Arrow is the last project before I talk about Quilt for a moment I want to make you aware of. And Arrow, if you look at the chart on the far left there, is really trying to save us from this world where we're spending 75% of our time on I/O. So this is virtualized in-memory data analytics, right? And you've got all these different sources. You've got Pandas, you've got Parquet, you've got Cassandra, and they're all fast and optimized. But when you start moving and shuttling data between these nodes, that's where you lose all of your performance gains. And the idea behind Arrow is that we can have one single virtualized in-memory analytics stack that anybody can query, any client can query, and you don't spend any time actually moving data around. Very exciting. Should be mature in the next 6 to 12 months. I think we'll start seeing deployments with it. Finally, this is my company. What we do is data package management. So the hole that we saw in the market was that people have developed very advanced techniques for managing source code. We have GitHub, we have SVN, we have Perforce, but data management is in the Stone Ages. And so what we want to do is a form of virtualization that allows people to manage data like code. So installation or packaging, compilation, making things high efficiency and binary is something that we do really well for code, but not yet for data. And that's the change we want to see in the world. And so how many people have data scientists working with them in their orgs? Okay, great. So the fundamental divide here is we have data scientists working in R and Python, and then data engineers or data analysis happening in Spark. And how do you bridge that divide? And I'm going to do a 30-second demo and then open it up for questions. Super. All right. So how many people, I should ask, are familiar with Python? Okay, good. I'm happy to see that. So you will get what I'm going to demonstrate here in just a second. So I mentioned that our goal was to help people to manage data like code. And the first thing that we do, again, this is all data virtualization because you can access these data frames. You can access them from any client, from R, from Spark, from Python. The first thing we do is, if you've ever done a git clone, we have something similar with data. So you do Quilt install from some namespace. Let's say I want to grab a bunch of example data. All right, so what this is doing here, this is going out to the cloud. This is pulling my data, materializing my data locally so that I can access it. And here's the cool part, right? So I've got this data package on my machine. I don't have to know anything about formatting. Remember Cod's quote from the beginning. And now in Python, the same way that I would import a software module, I can actually import data. And this data can then go into any client. So examples is a tree of high performance data frames. And even if these data frames are very large, because we have this data compilation step, there's actually no parsing whatsoever. So when I access a data frame, let's go like to world 100 meter, this is just a smorgasbord of data. There's actually there's I/O that takes place, but there's no parsing because we've already compiled or binarized that data and we're literally copying blocks from disk directly into memory. Okay? And of course, in this tree of data frames that you have, you can navigate that tree and discover all different types of data. And so our vision, really, going back to the presentation and wrapping up, is to change how data warehousing works and make sure that compilation is the very first step that people undertake with their data. So as data streams into the warehouse, we're going to be compiling it and packaging it, and that reduces your dark data because now everybody in the organization can access that data without thinking about where it is. And we're still at the level where it's a command line client. The other thing that's important is versioning, right? So if you want reproducible data models, you need a specific version of the code that's solved by Git and a specific version of the data. So all of the blobs or data packages that you put into Quilt are all hashed. So you can travel time, you can check out specific hash versions, and you don't have to worry about reproducibility anymore. Okay, so this is the last thing I'll say about Quilt. It's a 10x improvement. So on the left there is Python code and the steps you have to go through to get data into Python without a package manager, right? So it's a lot of emailing files, let me write custom parsers, oh, I've got some Excel files, I've got some CSVs, I got some TSVs. On the right-hand side, this from statement, which allows you to import data, I'm showing what we're doing at Quilt. And because the virtualization step, when you compile the data, handles the abstraction for you, people don't have to worry about file formats anymore. It's very exciting. Okay. That is everything I wanted to talk about. I know it was a lot, and I would love to spend a minute or two taking questions because there are so many things to talk about. But thank you for coming out, and I would love to hear your questions. Yes, I'll be around for the rest of the day. So come see me, especially if you're working data science. 3 thank yous, actually 5. So Joe and Ashley for having me out today, Ram, and my friends Brian, Abe, and Iga, who all got up early in the morning and are here to film the talk. So much love to them and to all of you. And if you, I don't know if we have time for questions now or you want to do it later?
Yeah, we'll do later.
Super.
I'll wrap up here in just a second. You guys need know where to go. Okay. So let's give Aneesh Karve a round of applause.